So today we want to continue solving trigonometric equations. We've gone through the 3 stages of solving trigonometric equations. In the first stage, that's way back at the beginning, we use an inverse trig function to find an acute angle sitting inside of a right triangle. Stage 2 is when we open up the rest of the circle, but only go around once. We use the inverse trig function for a reference angle and use the sine to determine the quadrants. And then stage 3 is where we're writing all the solutions. We do that by adding integer multiples of the period. That's 360 for or 2 pi for sines and cosines. Tangent has a smaller period. Tangent has a period of pi rather than 2 pi. And then we just have to start including the other information. We just have to start including other operations in our equations. These are the 3 stages of just doing inverse trig functions. So if we have, let's say, an equation that involves lots of stuff. Let's suppose that we have an equation that says 5 times the sine of pi over 10 times x plus 2 minus 3. And we want to solve this equal to, let's see, set this equal to 1. There are a lot of operations going on here, but we know all the operations that I put on the side with the function, the sine function, are going to be changes in amplitude, changes in the middle, changes in the period, and changes in the horizontal slope. The inverse trig functions for the reference angles, putting them into quadrants and getting all the solutions. That is all contained in doing the inverse trig function part. So if we were to read this equation and see what's going on, how does this equation turn x into a 1? So if we want to come up with a plan for solving this equation, we got to think about how this equation turns x into a 1. The first thing that happens is we add 2. After we add 2, we take this result and multiply by pi over 10. Once we've multiplied by pi over 10, then we apply the sine function. After we apply the sine function, I got to multiply by 5 and subtract 3. The order of operations says do the multiplication first. And finally, we subtract 3. And that's how we turn this equation turns x into a 1. So if we want to solve this equation, we're going to perform inverse operations in reverse order. So we're going to start with the inverse of subtracting 3 is adding 3. The inverse of multiplying by 5 is dividing by 5. The inverse of a sine is a sine inverse, and this is where we do all of our stuff, depending on what we're asking. Stage 1, stage 2, or stage 3. This is where we do the sine inverse, which is any one of these stages above. Then we can undo, instead of multiplying by pi over 10, we'll divide by pi over 10. And finally, we'll subtract 2. And that's how we'll turn 1 back into x. We're going to apply inverse operations in reverse order. Let's start with 1 and do these things. Now, if we're doing this on a machine, then we just grab our machine and start punching in the numbers. But we want to see this happen. I know that a lot of us are raised in the tradition of do the same thing to both sides of the equation, which is the same thing that we're doing here. We're just being more specific about what we're going to do first and second and third and so on. So first, the last thing that happened on the left is we subtract 3. So the first thing that we're going to undo is add 3. And so our equation is going to look like 5 times the sine of pi over 10 times x plus 2 equals 4. First thing, we'll add 3 to both sides. 1 plus 3, 4. Next up, we'll divide by 5. So that we'll have sine of pi over 10 times x plus 2 is equal to 4/5. I know I'm about to grab my calculating machine, so I'll just put that at 0.8. Third thing on my list to do is to apply the sine inverse. This is where we have to do a reference angle and then put that reference angle in the appropriate quadrants. So I need a reference angle. So I'll make sure I'm in radian mode because it looks like this problem is in radians because of that pi over 10. I didn't specify, but I'll specify when I actually ask you to do it. And we'll do a sine inverse of 0.8 for a reference angle, 0.927. So our reference angle is 0.927. And because this 0.8 is positive, we're going to put it in quadrant 1 and quadrant 2. I wrote theta r just because I didn't want to write pi over 10 times x plus 2 with a subscript to r, but that's our reference angle. So our actual angle, which is the pi over 10 times x plus 2, is 0.927 in quadrant 1, which is just 0.927. And then 0.927 in quadrant 2. So I have to take pi and subtract 0.927. So that'll be 2.21. So I need sine inverse to get my reference angle. My reference angle in quadrant 1 will just be the angle, 0.927. In quadrant 2, I subtract my reference angle from pi, or subtract my reference angle from 180 degrees, depending on what we're using. So I've taken my reference angle and put it in the appropriate quadrants. The other thing that we have to do is add multiples of the period. So to get all the solutions, I have to keep going around the circle and stopping at everything coterminal with 0.927. So I just say plus 2 pi times n. There we are adding full circles. Next step, now that we've done the sine inverse, all of that was just to do the sine inverse part. Next up, we need to divide by pi over 10, which is the same as multiplying by 10 over pi. Dividing by pi over 10 is the same as multiplying by 10 over pi. I'm just going to distribute this 10 over pi all the way through. That'll cancel out the 10 over pi, the pi over 10, and just leave an x plus 2. 0.927. No, actually, let's get more digits. If we take that 0.927, oops, I'm off screen, and multiply by 10 over pi, that gives us 2.952. And I also have to take the 2 pi and multiply it by 10 over pi. So 2 pi times 10 over pi is going to be 20. Because I can't just multiply the 10 over pi by the 2.2 or the 0.927. I have to multiply it by all the terms. Multiplication distributes over addition. Notice that if b is pi over 10, then the period is 2 pi divided by pi over 10, which is 20. And so we're still adding multiples of the period. Over on the other side, x plus 2, I need to take the 2.214 I'll take that 2.214 and multiply by 10 over pi and get 7.048. And I got to do the 10 over pi multiplied by 2 pi, and that'll give me 20 times n. Once again, I got to distribute. And then the last thing, step 5 in my solving of equation is to subtract 2 from both sides. I'm going to subtract it from the like terms. So subtract 2. I'm not going to subtract from 20n. Those aren't the same. This one's a 2. That's a 20n. Those aren't like terms. So x is equal to 0.952 plus 20n. And then I'll subtract 2 from the 7.048. So I'll get 5.048 plus 20n. And now we'll be able to write all of our solutions. So we could write 0.95. If we just wanted to write a list, it's 0.952, 5.048, and then 20.952, then 25.048, and the next one would be 40.952, and then it would just go on. We could also take the 5.048 and subtract 20. So go make the circles go the other way, and we'll have negative 14.952. And then the 20 minus the 0.952 is negative 19.048. Because of the shape of our function, we knew we were going to have infinitely many solutions. Questions? Is everybody okay? No is correct. You should not be okay. This is the most that I could throw at you for one of these problems. Thinking about the graph, thinking about solving equations, putting these weird ass numbers all over the place. You should not be okay at this point. So if you are okay, that's strange. If you're like, oh, nope, totally get this. This is super easy, barely an inconvenience, then you're the weird one. I think a lot of times when we're in math class, especially, we think we're like the only person in the room that doesn't understand what's going on because no one says anything. So for some reason, you look at nobody asking questions and say, oh, they all must understand. I'm the only one that doesn't understand. But then you don't realize you're also not asking questions. So maybe other people are experiencing the same thing you are. You know what I mean? Plus, we've spent like what, 2 days talking about solving trigonometric equations to this extent. You shouldn't be good at it at this point. You know what I mean? You know what I've done? I've gone out on a basketball court with a basketball and thrown it through the basketball circle. I have done that. Am I ready for the NBA? No. I've done one. I think that's my lifetime record. I think I've done that one time. I did it on my first time, so I have a 100% shooting record. I'm just kidding. I have missed many times. But all the misses have been so bad, I could say I wasn't trying for that. I was just trying to throw the ball away. My soccer instincts took over and I just kind of trying to clear it. You know what I mean? But yet for some reason, when we're in math class, we think that we could sit down, watch somebody do one example, and then understand what's going on. Dude, I have watched a lot of baseball. I am not going to be going to try out for the Giants. At this point, where I'm still paying attention to baseball, I could pick on the team that had the worst record last year and say, I might go out for that team. But I don't know who that is this year because I haven't watched baseball and I could never watch it again. Here's why. I'm a Giants fan and I stopped watching baseball before the 2010 season. And then what happened? Now I can never watch again because as a baseball fan, I have to be superstitious about this shit. I'm like, oh, well, I clearly can never watch again. Now we ignore 2011 because when you're looking for a pattern, you will find it. You just have to ignore any evidence that contradicts your position. So in 2011, they don't win. So I should be free to watch baseball again, right? No, that one was the fluke. Because, and that gets confirmed because I pay attention to 2012. When what happens again? We win again. 2 out of the last 3 seasons that I didn't watch, Giants win the World Series. Well, that settles it. More than half a chance. So we ignore 2013, and then what happens in 2014? We pay attention to that year. See, you only pay attention to the ones that align with your beliefs. You know what I mean? No, that doesn't apply to you. This is baseball superstition. This is something that I observed. I didn't watch in 2010, and the Giants won. And despite the fact that I am actually familiar with how statistics worked, baseball superstition takes over and says, no, no, no. Clearly they won because you didn't watch this year. Then I'm like, all right, superstitious portion of my brain, you sound like an idiot. What happens in 2011? And as I, shh, what happened in 2012? I'm like, oh my God, you're right. You know what I mean? This is why gambling is so effective on people. Because we are really, really bad at shit like probability. We know how to do the calculations, but that doesn't matter because we're playing a game. You know what I mean? Like if I jump up here and I take a coin out of my pocket and I flip it 10 times in a row, it comes up heads. What's the probability on the next toss that it comes up heads? 50%. To think that it's going to come up tails because 10 times in a row it came up heads is to think the coin must be bored of landing heads. And so it wants to change things up. So it's more likely to land tails. Right? That's what the thinking is. That's how gambling works. It's like, well, you know what hasn't landed on the roulette wheel for a long time? 00. Put $1,000 on 00. And like, oh, what the hell? You know what I mean? We are really bad at things like probability. You know, I'm not worried about getting struck by lightning. I don't play golf. So that keeps me from standing out in fields with lightning rods in my hand. And that reduces my chance of getting struck by lightning. Anyway, what are we talking about? We're super influenced by the things that we just saw. Go to the beach, go swimming in the water. And that's apparently a thing. It's Northern California, so the water's fucking cold. But go and watch Jaws, and all of a sudden you don't want to do it anymore. Oh, I might get eaten by a shark. Shark's not going to be there. Oh, that's what they said in Jaws. That was a movie. Yeah, but now I'm thinking of it. You know what I mean? Logically, we can tell ourselves that we understand that correlation is not causation. But the primitive, stupid part of our brain is like, oh, wait, hang on a second. You didn't watch in 2010 and they won, so better stop watching. Oh, yeah, that seems reasonable. Seems reasonable, also terrible argument. Never do something based on seems reasonable. For a long time, we watched the sun and said, the sun is going around us. That seemed reasonable. It's wrong. It's no justification for anything. Oh, but it seems reasonable. You know what I mean? So let the rich people keep all their money. It'll trickle down to the rest of us. Because what? Rich people are going to get bored of having all this big piles of money and start. If you believe that, that's fine. We have all at one point been subject to some kind of brainwashing, but there isn't any evidence of this. So, you know what I mean? But we want to believe it. So we do. We want to believe it. So we look for evidence of it, which is the opposite of what you're supposed to do scientifically. You come up with an idea and then you try to prove yourself wrong. If you're unwilling to do that, then you're not doing science. You know what I mean? Anyway, let's take a break. Come back and talk more about solving trigonometric equations. Oh, I hadn't paused yet. Include lots of babbling in your videos.